Let's compute the following limit. The limit as n goes to infinity of n squared plus n plus 3 over n squared plus 3n plus 5, everything to the power n. This is from Stanford math competition tiebreaker, and I think we have 5 minutes to solve this problem. So this is Stanford math competition. I think maybe 2020, I am not sure, but it's from Stanford. So here, if we, with the first thing that we do is that we can see blindly that this limit inside is 1, and 1 to the to infinity is undetermined 4. Therefore, we can't compute this one here. Okay, and even if we use the trick, we take the exponential of this one. So the exponential of e to the power n, yes, log of this quantity here, this one will not help. But we see that we can do some division here if we can. So here, let's see if we have some common factors. So the n squared plus n plus 3 has no roots. There is no root here because the discriminant is 1 it's minus 11, less than 0. And here we have n squared plus 3n plus 5. The discriminant is 9 minus 20. It's strictly negative, so there is no solution. But we have some hope here if we can divide using Euclidean division here. So if we can see, we can write this one here and the traditional way, n squared plus 3n plus 5, and we divide that by n squared plus n plus 3. So we have 1 minus 3 minus n squared. Therefore, we have 2n and 0. Okay, therefore we can write this one here. Okay, we can rewrite it. Yeah, I think this is the key. We can rewrite it here as n squared plus n plus 3 over n squared plus 3n plus 5 as, okay, this is n. Okay, so we can write it as 1 minus 2n plus 2 over 5n squared plus 3n plus 5. Let me just check if I can do that. Here I have n squared plus 3n minus 2n. It's going to give me n. Okay, it's going to give me n. This is n. Sorry about this handwriting here. N and 5 minus 2. It's going to give me 3. Yes, this is the right one. Okay, now when we do the... let's see what happens when we take everything to the power n. Okay, if we take this one to the power n, we're going to have 1 minus 2n plus 2n over n squared plus 3n plus 5 to the power n. Here, if we take the limit, we're going to have 1 and 0. Now, it's the same thing. We're going to have the same issue here. But here we have this power 2 to the power 2 times n plus 2 over n squared plus 3n over n. So we're going to use, okay, I see the problem here. We have to use some equivalent form, okay, of this one here. So here, 2n plus 2 over n squared plus 3n plus 5 is equivalent to 2 over n. Why? So these two are equivalent if we can, if we divide, we get the limit 1. So if we do so, we're going to get 1. And I think we can replace this one by just 2 over n, okay? So here, this is equivalent. They have the same limit. Either they are convergent or divergent, okay? So equivalency is the good thing to go. So here, so we have this one is, it's this one here, this limit. Now we see the problem. N squared plus n plus 3 over n squared plus 3n plus 5 to the power n as n goes to infinity is the same. If it's convergent, it's going to be the same as the limit as n goes to infinity of 1 minus 2 over n to the power n. Yes, so we see that this is just some exponent. Okay, here if I use the equivalency now, I'm going to get, so the limit e to the power n, the log of 1 minus 2 over n. Yes. So 1. So this one, we know that this one is just 2 over n. The log of 1 plus, so here the log of 1 minus x is the same as minus x. Okay, so here this is another thing that we need to prove, or it's assumed. Okay, so that means this one has to be equal to 1. Okay, but we can prove it using the expansion. Okay, I know that 1 over 1 minus x is 1 plus x squared, etc. Let me stop at x squared. If I integrate, I'm gonna get I need a minus the log of 1 minus x. So this is just x plus x squared over 2. Okay. Okay. So if I divide everything by x, okay, let's divide everything by x. We get the natural log of 1 minus x over x. It's 1 plus x over 2. Yes, and the minus here. Okay, so I need this minus. That's why I need this minus x. So this is true. So this is close to 0. If I want infinity, so I need to do minus the log of 1 minus 1 over x times over 1. That means times x. So times this x here. So it's gonna give me 1. So this one is equivalent to minus 1 over x. So minus 1 over x, that means as n goes to infinity, so this one gives me so this one will be, this is, we have the x here, we have 1 over n. So here we have the 1 over, so this is equivalent to minus 2 over n. Okay, so the limit here, so this one is just the limit as n goes to infinity of e to n times minus 2 over n. And I think it's, and this is a constant, so it's e to minus 2. Okay, 1 over e squared. So this is the limit. So therefore our limit is, it's tricky, it's not clear, but you have to do a lot of work for this. So here this limit is 1 over e squared. Okay, I don't know exactly how much is that, but it's 1 over e squared. And the key is using these equivalent limits. Okay, so if you have u sub n equivalent to some uvn, they either converge or diverge at the same time. Okay, well, we know this one. So this is the key to use here, okay, because we don't want to use this whole quantity here, so we switch to this one. Okay, and after that we use that the log of 1 minus 1 over x is just it's this quantity here times, it's minus this quantity here, minus this x. So it's gonna give us minus 2 over n, and with this n, with the n that we have here, when we raise to the log, the log, we're gonna get to the exponent, we're gonna get n. So we get rid of this by just noting that, so this is, this log here, 1 minus 2 over n is minus 2 over n. So this is the one that we need. So this is the one that we need here, and n times minus 2 over n is just minus 2, and therefore we get this constant. So this is the limit here.